guys, Miss Malik here. Today we're looking at exercise 4F from your essential textbook. It's looking at polynomials of higher degree and in particular drawing sign diagrams and graphs for those. So the first thing we're going to do, we're going to draw a sign diagram for this here. Now this one's a handy one because you can really easily solve for x. It's already in a factorised form. So we can just read for x. So find the solutions for x. We can say, well, x is going to equal 2 because 2 minus 2 is 0. X plus 2, x is negative 2. X minus 3, x would be 3. And x minus 5, x would be 5. Here is our number line. I've put those values for x in order onto there. I've labelled my x there. I should also actually label the negative and positive side of the number line. I've forgotten to do that, so just don't forget when you do it. I want to now know how the graph will look. Where will it be? So I'm going to choose a value in between negative 2 and 2. 1 is pretty easy there, so I'm going to choose 1 and I'm going to substitute that in. I get 24. So that means that between negative 2 and 2, I'm in the positive zone because 24 is a positive number. So my sign diagram has to look like that. Let's try this one here. This one's a little bit harder. F of x is x to the 4 plus x to the 2 minus 2. Now, we're going to have to factorise it so we can find our x values or the x-intercepts there. So to find the solutions for x, I need to find factors. And the first one, I'll just have to do a bit of trial and error. By substituting 1 in for x, so p of 1, I get x to the, 1 to the 4 plus 1 to the 2 minus 2. That gives me 0. So that means that x minus 1 is a factor. Let's divide using long division of polynomials. X into the x to the 4 goes x cubed. X cubed times x gives me x to the 4. X cubed times minus 1 gives me negative x cubed. Notice I put a 0x cubed in and a 0x in. That makes it easier for when I do my subtraction. So x to the 4 minus x to the 4, that's fine, that cancels to 0. 0x cubed minus x cubed gives me positive x cubed. Bring down the x squared and let's divide again. X into x cubed goes x squared. X squared times x equals x cubed. X squared times negative 1 is negative x squared. Let's subtract. X cubed minus x cubed, 0. X squared minus x squared, 2x squared. X into 2x squared goes 2x. 2x times x is 2x squared. 2x times negative 1 is negative 2x. By subtracting, I get 2x and I bring down the minus 2. Let's keep going. X into 2x goes 2. 2 times x is 2x. 2 times negative 1 is negative 2. Subtract and I get 0. It's important that you do get 0. If you get something else, it means that there's a remainder. How can there be a remainder? If something is a factor, there can't be a remainder. So you would have done something wrong if you get a remainder. So I can state that x cubed plus x squared plus 2x plus 2 is also a factor. That doesn't really tell me any of the x-intercepts though. It's a little bit hard to use. We need to do a little bit more division there. So now that I know that, I'm going to find out, I want to factorise x cubed plus x squared plus 2x plus 2. So I'm going to substitute p of negative 1 in, because I want to break that down. What I find is that p of negative 1 equals 0. So that means that x plus 1 must be a factor of that. And if it's a factor of that, it must also be a factor of x to the 4 plus x squared minus 2. So now I have two factors for my x to the 4 plus x to the 2 minus 2. Let's do some division again. Let's find out what the other factors are. So x plus 1 into x cubed plus x squared plus 2x plus 2. X into x cubed, x squared times x cubed, x squared times 1, x squared. Subtract, I get 0. X into 0 goes 0x. 0x times x is 0. 0x times 1 is 0. Bring down the 2x there and the positive 2. X into 2x goes 2. 2 times x is 2x. 2 times 1 is 2. Subtract and I get 0, as you would expect, because it's a factor. That means that I have another factor, and that is x squared plus 2. So far I've got x plus 1, x minus 1, and x squared plus 2. So what can I do with that? Let's find out if we can get any, if we can break down that x squared minus, plus 2. You could do it just probably more easily actually by just taking the negative 2 to the other side, or the 2 to the other side where it becomes negative. X squared equals negative 2 would mean that, well, you can't solve that because you can't square root a negative number. The other thing to think of is that, well, if the discriminant is negative, you've got no solutions. So with x squared plus 2, that's x squared plus 0x plus 2. B squared minus 4ac would be 0 squared minus 4 times 1 times 2, which equals negative 8. Negative 8, well, it's a negative number, therefore there is no solution for that. So what that means is that this is our factorised form, x plus 1, x minus 1, and x squared plus 2. It's a factorised form of x to the 4 plus x to the 2 minus 2. We have solutions for x plus 1 and x minus 1, but we do not have a solution for x squared plus 2. That means we have two x-intercepts. I'm now going to substitute in x is 0 because I want to know what the y-intercept is. I also want to know the shape of my graph in between positive 1 and negative 1 because they're my x-intercepts. So when x is 0, I get 0 to the 4 plus 0 to the 2 minus 2, which gives me negative 2. So in that case, it must mean that between negative 1 and 1, I have a negative part of my graph. It's in the negative zone. There's my sign diagram. So we're going to be finding the coordinates of the points where the graph of f of x equals x to the 4 minus 2x squared plus 1 crosses the x and y axes, and we want to actually sketch the graph. So the first thing we're going to do is we're going to find a factor of our polynomial there, and by substituting 1 for x, we find that that equals 0. So x minus 1 is a factor. By doing long division, I end up with a result of x to the cubed plus x squared minus x minus 1. I then can factorise this in a different way. I can do it by grouping 2 and 2. So if I take out x squared from the first two terms, I get x plus 1. So x squared times x is x cubed, and x squared times 1 is x squared. I can then take out a negative 1, which gives me x plus 1 in the second set of brackets. This is handy because when I factorise, I get x squared minus 1 and then x plus 1. Don't forget that where you've taken out that negative, you've actually taken out negative 1. So, of course, then when we take out our binomial factor, we can say x squared minus 1 times x plus 1 there. So, x can be 1 because x minus 1 has to equal 0. And x can be negative 1 because x plus 1 has to equal 0. X squared minus 1, if we are to then solve for x, we get x squared is 1 and x will therefore equal 1, which we've already got. So we don't need to write that in twice. X is 1 and x is negative 1 for that one. Let's substitute in 0 for x so that we can find the y-intercept. We end up with 1, so the y-intercept is at 1. To draw this graph, we can see it's going to be this shape here. So we touch the x-axis twice at negative 1 and 1, and we touch the y-axis at 1. So it's going to be like this. We know it sits on top of the x-axis because if it were to go below it, you would have 4 x-intercepts. We only have 2. So there's a clue there. And that's the end of sketching polynomials for f. Next time we will go on to 4G.